Hello world, it's Rational Pi. So Hitler, are you gonna get Windows 10? 9. No, Hitler, they didn't make Windows 9. Windows 10 is the newest operating system that Microsoft came out with. So are you gonna get it? 9. I don't think you're getting it. They're making 10 because it makes sense to go from 8.1 to 10 because that's edgy and it gets people going. 9. Alright, that's enough of that joke. I didn't really have anything further to go with that. I just thought it was funny because 9 means no in German. Okay, anyway, I'm here today to continue our MBA conferences project. And we're going to kind of take a detour because I refound something that would be interesting, I think, to everybody that's more interested with the A-star and searching algorithms. And before we get into that, I want to give a shout out to the Grim Creeper, who is one of my friends. If you have a chance, go check his videos out. He's got a couple of Gario videos up now. His can be primarily more of a Let's Play video channel, and I definitely know he would enjoy the support. So, the tool that I'm talking about is called OpenNero, and this is the website. It's code.google.com/p/OpenNero. It's part of the Code on Google platform, and it's a really neat application of the search algorithms and artificial intelligence. And its quote here is game platform for artificial intelligence research and education. And I actually use that in my artificial intelligence class, and I'm probably going to be using it in some of my classes moving forward. But it has a variety of different games and a variety of different applications for artificial intelligence. The one that I have worked in is the maze, where it's just a little maze and this little robot traverses it using the different search algorithms. And I wanted to show that off today. So here's the website, and whenever you come and visit the website, if you want to download this yourself, you're going to want to download the binary. You don't want to download the source because I couldn't get it to work and it doesn't seem to be working properly. In fact, it even says so on the website where you go to download it. If you want some more information, there's some more information on the OpenNero program. But I want to go ahead and fire it up before we actually go through any of the code or anything like that. So when you download it, it's going to be a zip file, so you're going to have to extract it, obviously. And then once it's extracted, this is what it's going to look like. The actual application can be found here. And this is what it's going to pop open to. It's going to open a little CMD box here, and it's going to open the actual GUI here. And it starts out on maze. So, and then it has training, battle, blocks tower, and Roomba. The Roomba's pretty neat. I actually got to play around with that a little bit. So then when you go to start, normally whenever you start with this for the first time, you just got a variety of different search algorithms that you can play around with and see here. But I went ahead and commented those out just so we can see the A-star search. Over here, it provides different information on the code while it's running. You can control the speed here, and as you can see, it changes over here in the corner. And then you can create a new maze. And then if you need help, there's help, and then start. So the robot's going to start here in the corner closest to you, and its goal is always going to be the little red flag over here. So let's go ahead and start it up. So as it's playing, it's always going to try to reach that goal. Its primary purpose is to reach that goal as best as possible. If it has to make a choice between two equally, like right here, it's always going to choose going to the right rather than going straight or to the left, because it knows that if it has to make a choice between going this way and this way, it's farther away going this way than it is this way, so it's going to always choose right. And it looks like this map is going to be pretty easy for the A-star algorithm to decide, because it looks like they had that nice big corridor here. And then it's going to go try to find this one because this one's technically closer to this over here. Now, every single column and every single row has its own individual node at each intersection. And the heuristic used, we mentioned heuristics in our last video, the heuristic used in OpenNero is called the Manhattan Heuristic. And what that is the current column you're at right now subtracted by the number of columns. So like, let's say there's 8 columns to the end and you're at column 3, then it's going to be 5 added to the same thing with the rows. So if you're at 5, 3, and there's 8, 8 total, then the total heuristic is going to be 8. So that's what's going to add to whenever it tries to decide what node is going to be best to head to next. So as you can see, the best path is highlighted in white, and it just follows that all the way down and over here and over here and over here. So let's do a new maze. Let's see how it goes, see if we can predict what's going to happen. And let's go ahead and reset, and let's go ahead and start it. So it's going to keep trying to go straight as much as possible, so that's why I went here, and then it's going to go here. I'm going to predict it's going to go this way. Oh, maybe not. Yeah, it looks like this one's going to try to go straight as much as possible because it started over here and had to go this way. So it's going to go around here, and it's going to turn, and then it might actually go straight to the goal. Let's find out. But this is a really neat program if you're just looking for some ability to work on AI programs and work on the different algorithms. This is a really easy way to do that, and it's all open source. It's completely free, and you can edit the code as much as you possibly want to try to figure out better ways for you and for the robot to learn its way from the start to the finish. And as you can see here, it has different actions that it's talking about. So if action 0 is when it wants to move one row over, and then action 2 is when it wants to move one column up, and then it can only go left, right, forward, and backwards. It can't go obviously in diagonals in this situation. And then one of the things that it learns while it's going is where the walls are located, and that's part of the challenge with the maze. And then once it's reached, it says goal reached, and then the AI engine is disabled, 100 for the final reward, and then episode 0 complete. So that's what it looks like. So let's go ahead and look under the hood and see what's happening here. So when we open the maze folder, you get all these pieces of code here. This is in Python. Python, in my opinion, is a lot easier to learn, but it can get complicated when you're trying to do a very complicated process. And so what we're going to do is we're going to look at the agent, because the agent is what's going to be controlling the robot, the agent.py, which is the agent Python file. And then we're going to look for the A* search. As you can see, it has all these different search algorithms in there, and it's really neat to go through and look at. The thing I really wanted to point at is the A* search agent algorithm is actually really easy once we are able to understand a generic search algorithm. The only thing different between a generic search algorithm, where it just goes based on path cost, is the idea of the heuristic. And we went over the heuristic in our last video, and that basically means, for example, if we're going from Oklahoma City to Denver, and we're going from Oklahoma City to, say, Columbus, which I think is about the same distance away, if we're just looking at straight plane mileage, if we're on the same plane, it's going to be easier to go to neither, because they're both about the same distance away. Now, obviously, I might be wrong. I have no idea on my geography, but roll with me here. But getting to Denver is a little bit harder because you got the mountainous area around Denver to get to. So the heuristic may be a little bit higher going to Denver than it would be to Columbus from Oklahoma City. So you got to account for that whenever you're doing real-world type of searching algorithm, or you're trying to find the best path to something. And a lot of shooting games, a lot of gaming today relies on these type of algorithms to properly find its path. So as I was getting at, the heuristic can be a very important aspect to a path, because while it may not seem a whole lot in our current example with the NBA conferences, it could mean a whole lot in a different example. So initialization, basically this just means that it initializes itself. Here's the reset, where everything resets itself to where you can start a new game. When you press that restart button, this is what happens. It resets the generic search algorithm, and then it resets the heuristic to the Manhattan Heuristic, which we went over earlier. NQ means you add a new node to the heap, and then the DQ means you remove that node from the heap. So let's go take a look at the generic search algorithm. And I'm thinking about doing a video just on the generic search algorithm because I feel like you know, we're already 10 minutes into this video. I may just do a really quick overview of it and then maybe do a separate video regarding the generic search algorithm, because that's what's the basis for a lot of these different search algorithms are. So let's go through that real quick. It initializes itself. Here's that reset button that, as mentioned earlier. There's the initialization. Here's where we decide what our next step's going to be. Basically it says here is our backtrack from the target itself, and we're going to change it to the row and column that we're looking at currently. And then if it's in the self.backpointers, and self.backpointers basically is the nodes that we've already visited, and then it's going to say return back to that node if needed. So that's pretty self-explanatory there. NQDQ, we went over that before. Get action, this is where things really start to happen. This is what decides what action we're going to be taking, whether it's going to be action 0, 1, 2, 3, what's going to decide if we're going to go left, right, forward, backwards. And that is just based on it's the current, since we know where the goal is going to be, we know kind of what the heuristic is going to end up being. So we use that heuristic, we use that data to figure out what action it is we need to take based on the current position of the robot. The visit function it decides where we visited already. It decides what if we need to go backwards in a specific step, or if we need to just move forward and there's no viable paths going back. Start basically just means we get our initial observations. The observations are the rows, the columns, and the heuristics. Here's the first action. This is the very first action that we choose, and it says here for the manual A* search we DQ our next node and check if we can go there. If we can, we do, and mark the next one. If we cannot, we have to follow the path to the goal. So that's what this act function does. At the end of an episode, that's where it says the reward, this is the end of the episode, and it resets. And then you can also mark the front, which basically means you're marking the next node that we're visiting because we're now visiting it. Mark the target, which is our goal. Mark the visited, which is the yellow that we saw while we're going through it again. And then we mark the path. It looks like my fire alarm's going off during my video, so I'm going to go ahead and end it here. I hope you guys enjoyed, and we'll go over the generic search algorithm in our next video. Like and subscribe is always appreciated. I think our fire alarm's done going off now, but I will still go ahead and end it, and we'll see you guys in the next video.